Taylor. I'm the open source community flag bearer for the NuPic open source project, and I guess for Numinta's open source stuff in general. First off, we're recording. There's a camera in the back. I've got some cameras set up in other places, so where we're doing sessions, I try and record for people who can't be here, who might be interested in what we're doing. So you might be caught on tape, just know that. If you would like to take any photographs or videos, feel free. This is a very open, transparent thing we're doing here, so if you want to use a hashtag for social media, it is #NuPic. Let me say thanks to everyone who has helped me with this hackathon real quick. Terry Fry and Taylor, they're at the registration desk downstairs. They've been instrumental for logistics and planning. Thank you, Jeff, and the rest of our NuPic engineers on the right here who will all be here willing to help you get NuPic installed, brainstorm about what you can do with your data. We've all got root on the back of our shirts, so if you see somebody with root, ask them questions, and if they can't answer it, they'll find someone who can. Also, thanks Cornell Tech. Are there any Cornell Tech students here? Okay. Well, thank you Cornell Tech anyway, for letting us use their space. Jeff, would you come up and say a couple of things to our hackers to maybe motivate them to do fun, interesting things?
Hi. Is everyone, I just saw this logo for the first time a few minutes ago. Does everyone know what that is? It's great. My wife says, "What's that picture?" I go, "It's a neuron." She goes, I think it's great. It was one of our community members created that design. Anyway, thanks, Matt. Thanks for all coming here. And we're excited to be here. This is our first hackathon outside of Silicon Valley. And so it's sort of a new experience for us, although we've done something before. Matt always runs a great show. And we're going to try to make this really valuable for you. I just wanted to put my personal thanks for you coming here. What we're working on at Numenta, and I assume what you want to work on here as well, I think is extremely, extremely important work in not just in the technology world, but actually for humanity in many ways. We are trying to, at Numenta, we're trying to reverse engineer the neocortex. We're making good progress at that. And we want to build machines that work on those principles. That's what NuPic is all about. It's the open source component of that. And I think the implications of this work are going to be very, very profound in the future. So we all get a chance to participate in that. It's not clear exactly how that future will play out and what time frames and so on. It's kind of a messy time right now, but it's something it's really happening. It's starting to form, and I think Numenta is at sort of the center of the next many decades of machine learning based on cortical principles and machine intelligence in general. So it's great to have other people to participate in that, and I know some of you come from a long way to be here. So we're going to try to make it all very successful for all of you. It's important work. And I don't really want to delay things much at all. I just want to thank you again for coming. And we're going to try to make this successful, and not just this event, but NuPic as a whole, and machine intelligence as a whole, and brain theory and all that stuff. So thanks for coming, and I'll be around here myself for a part of the day, and then I'll be back tomorrow. And so we can have lots of conversations if people want to chat. But I'm going to give this back over to Matt, who's really in charge and running everything, and is going to make it work. Thanks, Matt.
Thank you, Jeff, and your vintage hackathon t-shirt.
I got my new one back, I just didn't feel like changing.
No, that's good. This is 2 years old now. I like it. This is from our first hackathon.
This is from the first one?
Yeah.
Well, it's from the nicer one.
Okay, let me get through some boring protocol so we can get on to the real stuff. First off, resources for you. Everything that you need to know should be at numenta.org/hack. If you go there, it's got links to our schedule, to our code of conduct, to resources, to everything you need, where to register your hack, all that stuff. We will register on a website called ChallengePost, challengepost.com. If you're going to have a hack demo at the end of this, you need to register there. More info is on numenta.org/hack. All of these slides also, so these slides have a bunch of links in them that might be useful to you. You can also find them at numenta.org/hack. So today's schedule, I am doing the kickoff at around 10:30, or as soon as I'm done with this. We're going to have a couple of NuPic engineers show off a few samples of things they've done with NuPic using Chayton has a demo using the Unity game engine and feeding data from that into Nupik, and Austin has something with the Project Tango. So that should be interesting. At 11:30 to 12:30, we will be available probably there's a big conference room in the back here. So we'll have Nupik engineers to help you get Nupik installed if you're having problems getting it compiled and running on your laptop. At 12:30 to 1:30, in the room back behind the projection screen, we're going to have sort of a brainstorming session on music theory with Nupik. The idea behind this is to try and come up with ideas on how to encode MIDI data into sparse representations so that Nupik can start understanding music. I think this is really interesting. We have a special guest with us that's going to help. He's our in-house music theorist. Charlie Gillingham from Counting Crows is the keyboardist for Counting Crows, and he's also a computer scientist, if you didn't know that. So we'll be running that session and hopefully pick his brain on some music theory and how we can encode MIDI data into sparse representations. I'm going to give a short session on the state of Nupik at 2 o'clock at 2:30 here. Attend if you want. I'm just going to go around like what the community's like, what's going on in the community, what kind of projects are happening, where we're going, what we've accomplished over the past year. So it's more focused on people interested in contributing or in the development and the progress of what's happening with the Nupik project itself. And we also have Connor Russamano from OpenBCI, who brought a bunch of hardware stuff. OpenBCI does kind of DIY EEG kits. So they've got these little spider things that go on your head with contacts, and you can get EEG information from your brain. And we've had a couple hacks in the past of getting that data into Nupik and using it to control things. So that could be interesting if you're interested in that. Please attend that session. That will probably be back in this room behind the projection screen. Tomorrow, I've got nothing on the agenda except demos at 4. So if you're going to demo, be ready at 4 o'clock. A couple things about the facility. Emergency exits, you can see a sign immediately upon exiting this room. It says exit. That's where you go. All of the doors in here don't open pulling or pushing. They're all sliding. This has been a problem in the past, apparently. So just be aware of that. If it doesn't open, it's because you're doing it wrong. You slide the door back and forth. I mentioned bathroom codes earlier. The men and women have different codes. They're on the door on the way out. You just take a look. Our Wi-Fi here is Google Guest. It's very fast, and it's free and no password. If you're sleeping here, feel free. You might, hopefully you brought a pillow or sleeping bag or something, because there's no couches in here. But if you want to talk about accommodations, you can come talk to me later, and maybe I can give you some tips on where to crash. Okay, a little more protocol. You do need your badges. To get in the door tomorrow, keep this thing and bring it back tomorrow. On the back of it is the real important thing. This is what the security guards are going to want to see. So keep the badge. It also has a gift card for food. We usually provide food at these events. Because of logistics problems at this facility, we were not able to provide meals. So we compensated by giving you a gift card. If you can't find food out on the street, there's something wrong with you. There is tons of food around here. It's lots of places to eat. So please go use that gift card so you can go eat. There's trash cans all over the place. Please use them. I will be making sweeps every few hours or so to pick up trash. It's a lot easier if you just clean up after yourself. Be respectful of the facility. If you don't know if you should be touching something, come and ask me. I'll tell you if you can touch it or not. And also, please take a look at our code of conduct. It's a typical code of conduct. Don't do anything that's harassing or offensive to people. If you think it might be offensive, it probably is offensive. So don't come up with any hacks that might offend anyone. If you want specific details, read it here. Okay, for communicating at this event, obviously we're all in the same room, so that's one method. If you have technical questions that someone here can't answer, or you find an answer and you want to share it with people, we have mailing lists. You can go to numenta.org/lists. There's a general discussion list, which is probably your best bet, and there's one for development, and there's one for theory. So feel free to sign up for that. And remember, for those of you taking pictures of the slides, that the slides are available at numenta.org/hack, and they have all these links in them. We also have a chat room on IRC, which I'm sometimes on, and we also have a Gitter chat room. If you have a GitHub account, that's the one that generally has the most traffic for chat. And spread the word with the hashtag #HackNewPick. I like, it's a vanity thing. I love going through Twitter and seeing all the social media stuff. So, okay, a few questions before I go on. Please raise your hand if you've ever been to a hackathon before. A lot of people, that's good, okay. Who has actually compiled and built NewPick on their laptop? This is a better indication of how busy we're gonna be helping you. Okay, so maybe half, that's not too bad. Whoops. Who has run any of the example code, tutorials, stuff like that? Another, maybe half, good. Who has like taken their own data or manipulated their own, some type of data of their own and passed it into NewPick and done some own experiments? Cool, okay. Thank you, I appreciate it. So, some more resources for you, for those of you who did not raise your hand. On numenta.org, there's a link to the wiki, and I would say this is probably the best bet for like a getting started, is go to the wiki. The wiki is laid out in a way to kind of drive you in a path that will help you build and install, give you tutorials on how to use NewPick, and then how to learn like what NewPick is doing and the theory behind it and that sort of thing. So that's a good resource to start at. Here are some suggested links, especially for you hackers. If you're new to NewPick and you want to figure out what it's all about, we've got a couple of tutorials we call HotGem. It's about energy consumption over time. This is a really nice use case for NewPick because it recognizes these patterns in energy consumption in buildings really well. So both of these have screencasts and sample code and me talking on and on and on about how to build it out. So hopefully that's understandable. There's one for prediction and there's one for anomaly detection, which follows the prediction one. We also have a beginner's guide to NewPick, which is Scott Purdy gave at a previous hackathon, which is a really nice dive into like the details of encoders, how we encode scalar data, for example, into sparse representations. So that's a good resource. And there's a link here to a bunch of different code examples on our wiki. CPU usage, spatial pooling, temporal pooling, classification, all that stuff. So we have code examples of all this stuff. So if you see something that sparks an interest and you think, hey, my hack might fit in that, start with that and see if you can run those examples. We also have a bunch of old demos from old hackathons. Yeah. From old hackathons, I think 14 demos from the last hackathon, something like that from the one before. So if you want some ideas of what other people have tried at other hackathons, go there. If you do not want to use NewPick or you're not a Python person, you don't want to write Python code, there are other HTM implementations you could potentially use. We have HTM Java, which is a port of the NewPick Python HTM algorithms by David Ray. David Ray? He's right back there. Yeah, there you go. Embarrass him. Okay. And we have Comportex by Felix Andrews, which is right here, which is a closure implementation of HTM. It doesn't closely follow our Python implementation of the HTM algorithms like HTM Java does, but it's still an HTM. Okay, a little guidance about your demos. The most important thing, I think, is if you have an idea about something, think about your data. Think about, do you have a lot of data? Is it temporal? The biggest question is the data you're thinking about using for a hack temporal? Does it have a time component? Because if it doesn't, if it's just spatial, you might not have much success. A key thing about HTM, hierarchical, temporal memory is a temporal component of that. So make sure you have a temporal component in your data, or at least you can somehow give it a temporal component. Is there enough data? You're not going to learn many patterns from annual data points unless you have lots of data, lots of annual data. And does it have patterns is another question to ask yourself. Yeah, you have a question?
How much is enough?
Well, that depends. Probably not a question for this presentation, but I can talk afterwards about it. It depends on the patterns in the data, basically.
Being 1,000 data points is a minimum type of thing.
Yeah, that's good.
You can do less, but you really like it.
Yeah, you're going to need at least 1,000 data points probably no matter what. Okay, a great way to learn HTM theory is to build an HTM in your favorite programming language. That's great. I love it when people do this, but it's not a good hack because you're just standing here telling people about what they already know, and here's my HTM in whatever. So please don't make an HTM and do the hack. You can do it while you're here at the hackathon, but don't make it a hack demo. We'd be happy to help you do that, but it's not a good demo. Okay, so let's talk quickly about anyone having any ideas. Oh, we're right on schedule, so good. I've talked a little about music, so I'm really interested in encoding MIDI data somehow so that NUPIC can understand patterns in music. And this is an example that Jeff uses a lot when he's talking about the brain, about HTM, about the hierarchy involved. And we've actually had demos in the past. Our first hackathon, actually, someone encoded Pomp and Circumstance, the graduation song, into scalar values and passed it into NUPIC and had it predict the entire song. And like after about, I think, 22, 23 repetitions, it predicted the whole song completely, like perfectly. So that was impressive to me. But it wasn't like a true encoding because they hacked it into scalar data. So the real challenge here is how to get MIDI data or some type of musical representation into a sparse format that encodes more information than just the pitch of the note, right? Because there's more to music than just pitches of notes and durations of notes. So that's something I'm interested in. I don't know if I'll have time to work on that, but if you're interested in that, come to the music theory session we're having today, because that's what we're going to talk about. But I want to hear about your ideas. Who has an idea of something they want to do today? I would really love to hear about it because you might motivate other people to help you implement your idea. A part of this is building teams. So I know someone has ideas. Please raise your hand if you have an idea and you're willing to share it. Okay, you're close. Come here, just take the mic. What's your name?
My name is Tom Carswell, and my idea was to use NUPIC for spectroscopy and element recognition. When you look at absorption lines, they look suspiciously close to sparse data representations for certain applications.
What is
anyway.
spectroscopy? What's that?
Basically, you shoot light at something, and then whatever light doesn't bounce back tells you what's in the object that you're shooting the light at, or the light is passing from, depending on how you want to do it. But I can't think of a good way to make that temporal, because it doesn't seem like something that would depend on how long you shoot the light at it, for instance.
Roofing?
Maybe.
Okay, that's interesting. So if there's a video component to it in any way, and you can get SDRs over time, that may be something that you could predict, as long as you could somehow reconstruct those into something actionable. Yeah.
Is that the Xbox?
Oh, Connect?
Yeah. And that's what I'll be picturing this way.
I think that's more like motion capture. This is more of a static thing.
By the way, we do have a Connect in-house. One of our engineers brought a Connect. So that's something we've been thinking about doing too.
Do you want to just provide comments on this stuff?
Yes, I do.
I mean, you can sing, it depends on what kind of data you get out of it. Cortical.io did these word SDRs, And they actually get really interesting results without even the temporal component, just using the sort of semantic encodings of SDRs. And you might be able to do something like that. At least with the words, though, we were able to then say, okay, now we can sequence in sentences. You might not be able to do that, but it's still, even just the SDR component of the theory might be useful for you in some way. I just don't know enough about your data, but there are some situations you can do a limited set of what we do with spatial patterns, pure spatial patterns. So I just want to throw that out. It's something to think about.
Yeah, as long as the sparse representations coming out of this actually have semantic meaning somehow, which they should. So, there's a lot. Say your name.
Sure. My name is Chirag. I came to the last hackathon. I didn't get a chance to contribute a lot. So I've been reading about NewPick, and the hack that I'm thinking about, I'm not even sure if this is a good hack, but I recently read a paper, a Stanford paper, which was trying to predict outcome of baseball games. And they had compared about 6 or 7 AI, so-called AI algorithms and predicting what the outcome of baseball games is. So there's about 2,400 games in a baseball season, and they would train the data over some period, and they would try to predict outcomes for each team over a game. So we were thinking about feeding that data that's really available and see if you can get any easy predictions just by feeding the data.
Interesting. It might be even better if you can get events within each game as well.
Hi, my name is Sean. This is a pretty vague idea, but I'm interested in environmentalism. And so can we take some amount of data and use that to do something like, I don't know, turn off lights more efficiently, or decrease and increase the temperature of rooms based on if people are around? So if anyone is interested in something that's very vague, but lots of ideas with that.
We did a fair amount of work in that space, so I can talk to you about it.
Okay.
It's doable. Definitely. It works.
Yeah, maybe it's something with even New York data that's around that I haven't
Getting
looked
the
into.
data is the hard part.
Okay.
Sounds like an IoT application to me. It's for like a building. If everything's instrumented in the building, you should be able to predict when people are going to be in what rooms and when things are going to be used. Or yeah. Did you have something?
Hi, my name is Ashish. I'm working for doing a project for New York Presbyterian Hospital this summer on patient onboarding and also at home care post-discharge. So I'm trying to incorporate some kind of decision analysis before they get to the hospital. So like what makes people think which hospitals to choose and what is the decision making. I'm not sure how that translates into this project, but hopefully there are some applications somebody can help me with.
Do you have data? We can figure it out.
My name is Dave Petrillo. I had an idea for using HTMs to look at automotive data. So can we add just a few extra sensors to a car and get a better idea of what's wrong with the car for consumer applications, or get a better idea of how the driver's doing for performance driving applications? It seems like there should be more information in the data than just, okay, this sensor is too hot, and so then the engine's too hot, but instead the rumble came from the front right corner of the car, so the way that we sense it means the wheel bearing is bad, and could help make diagnosing cars for regular applications easier and faster. I don't have any data, but we could make some up or something.
So it definitely sounds like an anomaly detection application, and NewPick is pretty good at anomaly detection. So, I only have time for a few more, so keep it short, please.
All right, my name is Patrick Ryan. I am interested in trying to model student data. I have some generated student data based on students that are good and bad, and I'm thinking about making it temporal by encoding the student and the question and maybe taxonomies about that question, and then followed by their answer and whether or not it was correct. It's just a simple, 1-2 sequence, but it might work.
So I'm not sure that's temporal enough.
Yeah.
So think about the temporal aspect.
Hi, I'm Steve Doubleday, and for my dissertation I'm trying to model interaction between the hippocampus and the cortex, and there's a particular rat experiment that I'd love to be able to, I've started to try to put into NewPick, but only gotten a little way in, and that has to do with a rat will project out of their hippocampus a trajectory about where they're going to move. And if you if you were to feed in the trajectories that get generated by a rat or a simulated set, which I've got out of the test framework, the question is can, over a period of time, can our algorithm predict which trajectory is going to result in a reward and which won't? So that's what I'm tackling.
Interesting. Okay, I'm gonna do you.
This guy over here.
Okay. Okay. Four more. And I've already picked them. So.
Hey, my name's Scott. So I consider using anomaly detection for fraud detection in the mobile space. So right now, mobile advertisers, publishers specifically, are left to sort of set up their own metrics using mostly thresholds. If you can use simple device identifiers like the IDFA, the country, maybe their locale in the operating system, you could potentially do some useful things in detecting the types of traffic and then determine anomalous things and present that to a team of security people working for an app. I think, yeah, right now in the mobile space, like I said, a lot of publishers are having to do this on their own, and I think it'd be useful to consolidate that and create some service around that. Testing that out and trying that out could be a fun thing to do.
Definitely a lot of people interested in fraud detection. Yeah, it goes along with anomaly detection. Rogue behavior detection is another thing we've worked on.
Hi, my name is Marcin. So I saw a couple of days ago there was a quite interesting analysis of the LSTM units. There was some guy posted this on from Stanford, I guess. And I figured out, well, let's try to create a little bot, where you just feed the sentence, and say hi, and try the network and see what the network is going to come up with. That previous person fed like a bunch of Shakespeare's as well as Wikipedia as well as kernel source into pretty wide LSTM unit, and got some very interesting answers. So you could have, I guess, if the NUPIC network is deep enough, you can have a very sensible conversation, right? So let's see.
I'm Frank Rose. As part of trying to understand the NUPIC algorithm, I was interested in doing a sensitivity assay of the algorithm itself using generated data trained on a classification problem, and then perturb that data and see, okay, where does the classification start breaking down if you add randomness or drift or something to the input patterns. So maybe even be able to compare the performance of the Python version and HTM and Cortex.
Hi, I'm Paul. I work for this company that makes Muse, this brain sensing headband. It's an EEG device, and we want to use it for something pretty simple. HTM for something pretty simple of just recognizing muscle movement of like blinks, winks, forehead crunches or things like that, and maybe later use it for brain sensing.
Yeah, that could be interesting.
Hey, my name is Vladimir. I'm working with time series a lot, financial and economic time series, and my idea was to test the performance of HTM in kind of non-stationary environment. So I'd like to generate a kind of theoretical time series with time-changing coefficients, so time-changing patterns, and see how HTM can just recognize patterns in kind of adaptive non-stationary environment.
Hi, I'm Fergal Byrne, and I want to hack the theory, basically. So if people are interested in talking about, I have a couple of ideas that are kind of extensions of HTM, and I'm basically going to be interested in brainstorming those things over the weekend. So I'm also really interested in the non-stationarity thing as well.
Hey, Fergal.
Hey, how's it going, everyone? I'm Connor from OpenBCI. I'm interested in taking an OpenBCI device and plugging or connecting 16 channels to the kind of lower forearm and seeing if we can use NUPIC to classify individual finger movement. Because right now I've got a system rigged up where I've got a single EMG input that can make a hand flex in like an analog motion, but I'm really interested to see if we can identify individual fingers. So.
Okay. Anybody else?
My idea, first of all, I was reading about the complex adaptive systems and from a different book. And it seemed like it used genetic algorithms in order to have to solve the problems in its nature. But I want to embed a brain into it so that it, like NewPick, go into that adaptive system to make it better. There are some papers that actually combine the two, but it was only one paper that I found. So I'd like to be able to do that within Mathematica, because Mathematica can actually use, what do you call it, the video card, the GPU, in order to compute things much faster, and it's easier to code. So I was planning to actually implement it, you know, the algorithms in Mathematica.
That would be interesting. I don't think that would be, I would accept that demo as an HTM implementation within Mathematica. That's interesting.
Yeah.
Just a quick question. Yeah. Does NewPick use GPU for
There's a lot of interest in getting NewPick to run on the GPU, and I think I've seen other HTM-like implementations running on the GPU, but we currently don't. Eventually, I'm sure we will.
Hello, we are Cortical.io, and we are trying to combine your HTM and our Retina API to detect anomalies and/or patterns on text data or text streams. And if you guys working with text data, feel free to try our API, Cortical.io.
For free?
Yes, for free.
So if you're at the hackathon and you want to use Cortical.io's API, which is really cool, talk to these guys and I'll give you an API key.
Hi, my name is John Ye. I'm working on two projects. One is a acoustic project that by listening to the noise of the faucet sound, we want to be able to detect which faucet and hot or cold and where it is. And the other one, I'm starting to kick around this idea. It's actually using the switch matrix on the FPGA device. Instead of hard coding the actual FPGA, we want to be able to do the weighted learning as part of the switch matrix on the FPGA, because that's an unexplored layer of an FPGA device.
First hack mentioned about audio analysis, not MIDI, but audio. So there are others here. I know Richard is interested in audio waveform analysis, that sort of thing. And I've done some experiments with that too, largely unsuccessfully, but that's my fault. Anybody else?
So my hack that I'm planning to work on this weekend is called market patterns, and the idea is the assumption is that there are patterns in the stock market that we can learn to detect. There are lots of traders that learn these patterns by looking at charts. So I want to see, can we encode the data in such a way that NewPick can see patterns and just predict, ups and downs, not prices, just directions.
We've been nominally successful with stock volume prediction, so I know that's possible. Okay.
Hi, my name is Jiang. I'm interested in analyzing pattern, like intellectual properties. So my idea is more of like classification of patterns. So how valuable your patterns are. It's kind of a vague idea, but that's what I'm interested in.
What's the data?
So it's like pattern claims. So you can, patterns, yeah.
Please.
I think it might be wise for, especially if you're new to NewPick, if you've got an idea and you think of creating some data and running through it, you have some data, try to find one of the Numenta employees and just discuss it a little bit. It's very easy to make incorrect assumptions about how the data should be, the sampling rates, and what is temporal data. So if you have even any thoughts at all, it's really useful. More people trip up on the data, I think, than anything else. So it's worth grabbing one of us and just say, hey, that's what I was thinking of doing. I'll give you some advice.
You run in circles for a long time, and then we'll come tell you, oh, your data's in the wrong format. Okay, so that concludes the kickoff. Let's do like a 15-minute break, and I'm going to bring Chayton and Austin up here to talk about some of their hack samples with Unity Game Engine and Project Tango. Thank you. Thanks you all for coming.